So here we're asked to perform the integral, and we're doing it with respect to x. The equation is 10x e to the x. So I need to figure out what technique to use, and my first inclination would be to use the integration by parts method. That's because I can see I have an x tied up in two different sections of the equation. So I have an x out the front here, and I have an x tied up within the exponential. There's no way of combining them, so that really tells me I need to use integration by parts to get around it. Of course, you can consider integration by substitution, but in this case, there's nothing really that can be done with that technique. Really, the main reason is that the x's are of the same order, so it's just not going to work out. So let's go with integration by parts, and that means that we need to let one section of the equation equal u and the other part equal v dash. So from a bit of experience, what you should find is that this part here should be the part that's equal to u, and this part is going to be equal to the v dash. So let's take it over here. Alright, so the reason I've picked it in that order is because we're going to take the derivative of u. And when we do that, it's going to go to 10. Alright, and we can see that we've dropped a degree. So we started with an x, and then when we take the derivative, it's going to a constant, which is really good. We should be able to see in a moment that that's going to mean we can just directly integrate what falls out of the integration by parts equation. Okay, this one here, we want to go from v dash to v. Okay, so integrating e to the x, we're going to just be left with e to the x. Remember, if you ever want to check, if you take the derivative of v, it should go back to v dash, okay? So yeah, it works both ways. Alright, so let's go and use our equation for integration by parts. And that's that u v dash with respect to x being integrated is equal to uv minus u dash v dx. Alright, so this is this. So let me just quickly pop it in. And now this side of the equation we can get from what we've worked out. So u is equal to 10x, v is e to the x, u dash is equal to 10, and v is equal to e to the x. Alright, so as you can see, what happened here is that we've lost the x now inside this integration, which is really good because we should be able to then integrate it directly. So this stays the same. So 10, that's just a constant, can leave it as it is. And then integral of e to the x with respect to x, we did it a moment ago, it's just going to be straight back to e to the x. And because this is an indefinite integral, i.e. we don't have bounds on our integration, that means that we're going to have to leave in our little constant, our integration constant in the equation. So that there becomes the answer to our question. So the integral of this equation is equal to this. So that's all there is for that video.